In this class, we're going to continue our study of Modern Arithmetic 2. We're currently in Lesson 6, so this video or this class will cover Lesson 6 in Modern Arithmetic 2. Remember that the title of this course, or the title of our textbook, is Intellectual Arithmetic. So we're not just looking to find answers, we're looking to think about mathematics in a more mature way as we grow up and learn to use our thinking and reasoning skills and not rely on sensible objects like we did when we were younger. So before we begin, let's take a minute and prepare our notes for this class. This is Modern Arithmetic 2. Modern Arithmetic 2. Modern Arithmetic 2. We want to keep reminding ourselves that this is a different kind of arithmetic we're studying. It's called intellectual arithmetic. And we're on Lesson 6, right? Lesson 6. And in Lesson 6, we're going to begin to study subtraction, what's called subtraction. Now, just to remind you, we say this is intellectual arithmetic, and when you look at this book, I know when I first saw this book, I was a teacher. So I wasn't a student when I first saw this book, I was a teacher, and I looked at this book and I said, this book is like the same thing as Arithmetic 1. What's the point of this book? It looks exactly the same. You know what the difference is? What?
The count objects in our mind.
Right. Okay. But when I first learned about this book and when I first looked at this book, I was a teacher and I said, this book looks just like Arithmetic 1. And I thought, why would we do that same book all over again? That doesn't make any sense. But then I saw that the title of the book was Intellectual Arithmetic. And I studied more about what intellectual arithmetic means, and I learned what the difference is and how this book is different. And I want to make sure that as we go through this book, we keep reminding ourselves that we're not simply trying to find answers in arithmetic, we're trying to understand solutions, right? So in Arithmetic 1, if you were asked to count something, you were told to get something like beans or coins or buttons and count them, right? You'll see some kids in school, when they're asked an addition question or a subtraction question, they'll pull out their fingers and they'll start counting on their fingers, right? You'll see kids count on their fingers. What's wrong with counting on your fingers? What do you think? It's for babies, right? It's for students who can't think of numbers, and they have to have some sensible object to count or add or subtract. And in intellectual arithmetic, we don't want to count with our fingers. We don't want to use buttons or beans or anything else. In intellectual arithmetic, you're now 9, 10, 11 years old. You need to start to learn to think about arithmetic in your minds without any counters, without any physical objects. Okay? So that's what we're trying to do. That's the difference of this book. So if you have already studied Arithmetic 1 and now you're working in Arithmetic 2, a lot of these problems may look exactly the same as what you saw in Arithmetic 1. And you may say, oh, this stuff is easy. I already know the answers to these questions. But there's a difference, right? The difference is we want to move away from sensible objects and we want to learn to think about numbers without sensible objects. So let's look at Lesson 6 here. Let's look at Lesson 6. The first question we read, James had 2 apples and gave one to his brother. Is that intellectual arithmetic? Look at question 1. James had 2 apples and he gave one to his brother. Is that intellectual arithmetic? No. Why not?
Because to ask for the answer.
No. Why? Is that intellectual arithmetic? No, because they're asking us to count objects, right? We're told James had 2 apples. And so you're supposed to think about 2 apples, or you're supposed to take 2 counters and say, okay, James has 2 apples. These counters are like the apples, and he gave one to his brother, and so you move one counter out of the way, and then you ask, how many did he have left? And you look at the counter and you say, 1, right? But that's arithmetic 1. So that's not what we're doing here. Pay attention. That's not what we're doing here. Now let's look at the answer that they give us, right? James had 2 apples and he gave one to his brother. James had 2 apples and he gave one to his brother. How many had he left? What's the answer from arithmetic 1? What's the answer? 1. Is that what we want in intellectual arithmetic? No, we don't want the answer, right? Answers are easy. What do we want in intellectual arithmetic? Not the answer, but solution. Good. We want to know the solution. We want to know the explanation for how we find the answer. Okay, so now if you look, there's another question. What's the next question in number 1? No, number 1. We were asked how many had he left, and we said the number is 1. What's the next question we're asked in number 1? We're asked another question. That's not the end.
Why?
Why? Right? So we're not just asked to give the answer. 1, babies can do that, counting counters. I could use a calculator to find the answer. What we're trying to make sure we learn is the answer to the question, why? If James had 2 apples and he gave one to his brother, how many did he have left? What's the answer? 1. The answer is 1. Why is the answer 1? Don't worry about what anybody else says. You're responsible for yourself. Why is the answer 1?
Because 2 from 1 equals...
No, you read that wrong. No. 2 from 1 does not make 1. Be more careful. Because 1 from 2 leaves 1. James had 2 apples. He gave one to his brother. How many had he left? What's the answer? 1. Why?
Because 1 from 2 is 1.
Because 1 from 2 is 1. So that's our simple answer. That's intellectual arithmetic. We know, pay attention, we know that 1 from 2 makes 1. How do we know that? We memorize our arithmetic facts, right? We're going to memorize that 1 from 2 makes 1, leaves 1. 1 from 2 leaves 1. 1 from 2 leaves 1. We memorize that as an arithmetic fact. And then if you ask us any question about any objects where someone has 2 objects and they give away 1 or they lose 1 or they spend 1, we don't care what those objects are. We're not going to think about the objects. We're going to think about the numbers, right? That's intellectual arithmetic. We're not going to think about the apples. We don't care about apples. If you ask us a question like this, you're asking us an arithmetic question. You're not asking us a question about apples. I don't have to go talk to a farmer who grows apples to ask him if James had 2 apples and he gave one to his brother, how many does he have left? Do I need to talk to someone who knows about apples? No. This is an arithmetic question. And if you ask me an arithmetic question, I'm going to think about what? Not apples, not objects. What am I going to think about in arithmetic? What am I going to think about? Not the apples. Not the objects, but what? The numbers. I'm going to think about the numbers. This is arithmetic. In arithmetic, we think about numbers. We talk about numbers, not apples. We're not farmers, right? So if you ask us if James had 2 apples and gave one to his brother, we don't care about the apples. We just want to know that there were 2 and he gave one away, no matter what it was. It could have been ladders. It could have been buckets. It could have been bicycles. If I say James had 2 bicycles and he gave one to his brother, how many does he have left? It doesn't matter if they're bicycles or buckets or broomsticks or apples or orange. It doesn't matter. All that matters is 1 from 2 leaves 1. That's all that matters, right? That's intellectual arithmetic. Question 2. Question 2. Joseph had 3 apples and he lost 1. How many apples had he left? What's the answer? 2. Why? Because 1 from 3 leaves 2. That's why. Now we know why he had 2 apples in question 1, right? Because he lost 1. Oh, that's Joseph. Sorry, it's a different kid. All right, question 3. Thomas had 4 cents. He had 4 cents. Thomas was wealthy. He had 4 cents. And he gave one of them to Frank. How many had he left? Just answer the question. What's the answer? 3. Why? Why?
1 from 4 leaves 3.
Because 1 from 4 leaves 3. You see, what's funny is you'll joke about how easy these problems are, right? But when you have to explain why, you realize you have to really think about it, right? You have to think about why. And you have to think about giving an explanation for how to find the answer, because that's a solution. Okay? Let's do another one. Now we're going to stop talking about objects. We're going to stop that baby stuff. Look at number 4. There's no more objects, right? In number 4. The first question in number 4 asks, 1 from 5 leaves how many? 4. And we don't have to ask why, because that is why. We're talking about the numbers. 1 from 5 leaves how many? 1 from 5 leaves 4. Isaiah, 1 from 6 leaves how many?
1 from 6 leaves 5.
Good. 1 from 8 leaves how many?
1 from 8 leaves 7.
Good. And 1 from 10 leaves how many? 1 from 10.
10 is 11. No, I mean 9.
1 from 10 leaves 9. Okay? Good. Think before you speak, right? Think before you speak. There's no rush. There's no rush. There's no rush. Okay, moving on to number 5. John had 4 cents and he gave his sister 2. John had 4 cents and he gave his sister 2. How many had he left?
The answer is he had 2 left.
2. Why?
Because 2 from 4 leaves 2.
Very good. Because 2 from 4 leaves 2. Question 6. James had 5 apples and he gave his brother 2. James had 5 apples and he gave his brother 2. How many had he left? Yeah. James had 5 apples and he gave his brother 2.
He had 3 left.
3 left. Why?
Because 3 take away 2.
No.
5 take away 2 is 3.
Because 5 minus 2 is 3? Or because 2 from 5 leaves 3, right? Okay? So now look at number 7. What do you notice about the questions in number 7? How are they different? How are these questions different in number 7?
Because I already explained why.
There's no objects, right? There's no objects. We're just asked about the numbers and the relationships between the numbers. And that's intellectual arithmetic. Do you understand that? We don't need to think about objects. We're not babies. We don't need to talk about apples and cents. We can just talk about numbers. We can think about numbers. So number 7, 2 from 6 leaves how many?
2 from 6 leaves 4.
Good. 2 from 6 leaves 4. 2 from 8 leaves how many?
2 from 8 leaves 6.
2 from 8 leaves 6. 2 from 11 leaves how many?
2 from 11 equals 9.
Leaves 9. Good. Okay? So we can see that in question 7, the questions have no objects. There's nothing to count. We just think of numbers. That's intellectual arithmetic. Number 8, Thomas had 5 cents and he lost 3. Thomas had 5 cents and he lost 3. How many had he left?
The answer is he had 2 left.
He had 2 left. Why?
Because 3 minus...
No, that's not how you say it. Just follow the example and the solution. You don't have to reword it every time. Say the same thing.
3 from 5 leaves 2.
Because 3 from 5 leaves 2. You don't have to pretend you're a poet and you have to rewrite the sentences. Just use the same solution that they show you. Use the same form. It's okay. All right. That was number 8. Number 9, what do you notice about the questions in number 9? What do you notice that's different between the questions in number 9 and the question in number 8?
Number 9, one of the numbers by fruit says fruit.
Okay, so we're moving up to a higher number, but that's not what I'm asking about. What's the difference between the questions in number 9 and the question in number 8? What's the difference?
There's no object.
No objects in questions 9, in number 9, right? There's no objects. So in question 9, we have 3 from 6 leaves how many? 3 from 6 leaves how many?
3 from 6 leaves 3.
Leaves 3. Good. Next. 3 from 8 leaves how many?
3 from 8 leaves 5.
Leaves 5. Good. 3 from 10 leaves how many?
3 from 10 leaves 7.
Good. 3 from 11 leaves how many?
3 from 11 leaves 8.
8. Good. Okay, that's number 9. Now we can keep going with these. We can keep going, and you guys know the answers to these questions. You just need to think about it a little bit. And you need to learn to answer the questions why. That's the challenge in these lessons. Not finding the answer, but answering the question why. Thinking about the numbers and not the objects. Let's go on to the next page and go down to the bottom of the next page. At the bottom of the page, we read about subtraction. So this is subtraction. What we're doing in this lesson is called subtraction. We read at the bottom of that page, subtraction is the process of finding the difference between 2 numbers. Subtraction is the process of finding the difference between 2 numbers. Addition is the process of finding the sum of 2 numbers, right? When the 2 numbers are added together, we find the sum of those numbers. But subtraction is the process of finding the difference between 2 numbers. When we do subtraction, the larger number is called the minuend. Minuend. Say that. Minuend. Minuend. That's the larger number. That's the number to be diminished, or that we take away from. The smaller number is called the Subtrahend. Say that. Subtrahend.
Subtraction.
The result of subtraction, the result is called the difference or the remainder. Remainder means the amount that's left behind. The remainder. Okay? So, in a subtraction question, what is the name of the larger number? In a subtraction question, what is the name of the larger number? What is it? It's right there in your lesson. I'm not asking you to figure something out from outer space. Look at your lesson. We just read it. What is the name of the larger number in subtraction?
Minuend.
Minuend. Good. What is the name of the result of a subtraction problem? What is the name of the result?
Remainder or the difference?
Good. The remainder or the difference. What is the name of the smaller number in a subtraction problem? Say it.
Subtrahend.
Subtrahend. Good. You're not paying attention. It's not a mystery. You have to pay attention. It's right there in your book, right in front of your eyes. Subtraction is the process of finding the difference between two numbers. Recite that. Repeat it with me. Ready? Subtraction is the process of finding the difference between two numbers. Say it with me. Subtraction is the process of finding the difference between two numbers. That's a definition of subtraction. So there in lesson 6, you see that there are a bunch of questions. 25 different questions, and some of those questions have a number of questions. So there are probably close to 100 questions there, maybe 75 to 100. All right? You need to go through all of those problems and test yourself. You hear me? You need to go through all those problems and test yourself and practice subtraction. Learn how to give the answer and learn how to answer why. Learn how to give the solution. Give the answer and also give the solution. Okay? Don't just lazily give the answer. That's not what we're doing. You have to learn to give the solution. And I want you to flip and look at the next page in our book, what we're doing next. You see the next lesson, lesson 7, is memorizing all the subtraction facts. Okay? So you've got your work cut out for you. You've got to complete all the exercises, all the questions in lesson 6, and you can start getting ready for lesson 7 because we're going to study all of the subtraction facts. Okay? So subtraction is the process of finding the difference between two numbers. The larger number is called the minuend. The smaller number is called the subtrahend. And the result of subtraction is called the difference or the remainder. In intellectual arithmetic, we're not just trying to find answers. We're not just trying to find answers. Students can cheat in school and get the right answers. That's not what we're doing. That's fake arithmetic. What are we seeking to do in arithmetic? We're not just looking for answers. We're looking for solutions. Because that's when you can tell that you understand arithmetic, when you can give the solution, not just the answer. Cheaters can give answers, but cheaters can't give solutions. Okay? So that's all for lesson 6. Take a few minutes and write a summary of what we studied in lesson 6. Write a summary of what we studied, what we talked about. And that's all for lesson 6 in Modern Arithmetic 2.